Welcome back to Advent of Code 2021. So, we have completed everything Advent of Code has had to offer over the past decade, except for 2021, because I did them in the weird order. Well, I started with 2019 live. Then I think the next one I did live was 222, 23, 24. And then I went back and kind of did all the archived ones. So yeah, 2021 is the last one on the list, and then we're all caught up. And we'll have the much coveted 500 stars. Let's check this leaderboard, because I guess some people may have already done some of it. Smab UK, of course, has done lots of it. And Pararonia. Alright. So. Let's begin. Day 1, Sona Sweep. Alright. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Sleigh keys? Or the keys to open the sleigh. Alright. Before you know it... I mean, who steals a sleigh? Before you know it, you're inside a submarine the elves keep ready for situations like this. It's covered in Christmas lights, because of course it is, and it even has an experimental antenna that should be able to track the keys, if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, yet again, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. Well, we've got half a year to do this by. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby sea floor. On a small screen, the sonar sweep report appears. Each line is a measurement of the sea floor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report. It's kind of going up and down. This report indicates that, scanning outward from the submarine, the sonar sweep found depths of so-and-so. First order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. How many measurements are larger than the previous measurement? Okay, easy enough. Nice warm-up. Let's get the... D. I captured this correctly? Yep. Alright. So we've got that. Alright, so we've got with open input.txt. So we'll just load in the values. Just call them nums equals. So we want int line for line in f.readLines. Let's just check that works. So we've got our nums. Yep. All right. And then we just want to say for I in range 1 length of nums. So to the end of the list, if nums I is strictly greater than nums I minus 1, just print result. So we just add 1 every time it's bigger. What? Nums I in range, starting from 1. Hang on. Let me look at this again. We've gone off the end. Have I... Length nums... Oh yeah, of course, you don't add 1 there. Oh man, I have to relearn how to code. 1226. Correct. Alright. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example. Start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A. Okay, so it's the first 3 and then the next 2, 3, 4 and then 3, 4, 5. And take their sum, okay. Alright, I get it. So we want to just look at the windows. So that was part 1. This time, we want to say for I in range -2. Because we don't, so the last triplet will be where we have the third last number, the second last number, and the last number. So that'll be -1, 2, -3, +1. So yeah, length nums -2. And if, so So we basically want if it's gonna be like nums I plus nums I plus 1 plus nums I plus 2 is greater than, and then it will be nums I minus 1 plus. Now look, those cancel out, don't they? So it's actually, we're actually just calculating that. If the tail of the second triplet is bigger than the head of the first triplet, because the other two values are common to both. One, 2, 5, 2. Correct. That is day 1. All right. So we are on to day 2. Day 2, dive. Now you need to figure out how to pilot this thing. It seems like the submarine could take a series of commands like forward 1, down 2, or up 3. Forward increases the horizontal position, down increases depth, up decreases depth. Note that since you're on a submarine, down and up affect your depth, and so they have the opposite result of what you might expect. Okay. The submarine seems to already have a planned course. You should probably figure out where it's going. Your horizontal position and depth both start at 0. Steps above would then modify them as follows. So forward would add 5, down would add 5. Yeah, okay. After following these instructions, you would have a horizontal blah, blah, blah. Okay, multiply them together. Okay, that looks easy. Even easier than problem 1. Not, well, parsing might be slightly less easy, but still pretty easy. Okay, so so we guess we want so we could say x y equals 0, 0. Y is the depth. It goes down, so it's not Cartesian y. It's like computer game y. Computer graphics y even. Okay. So we split it into 2. If A is forward, then we just add. LFA is, so it's just 3 forward, down, and up. All right, so down, y plus equivalent b, a equals up, y minus equivalent b, and then we just want to just multiply the two together. It's that. Correct? Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll also need to track a third value, aim, which also starts at 0. The command also means something entirely different than you first thought. Down X increases your aim, up decreases your aim. Forward does 2 things, increases your horizontal position, increases your depth by your aim multiplied by X. Okay. Got it. Okay. I think we don't need to read through the example. So we basically just do this again. But slightly different. Right, so this start is 0 again, and this time, if it's forward, it said, so we've got aim. So if it's forward, aim plus, so what did it say? No. Forward increases your horizontal position by X as before, but it increases your depth by your aim multiplied by X. Okay. Okay, so X plus equal int B. And the depth Y times your aim. Okay. If it's down, then your aim is increased by B. If it's up, your aim is decreased by B. Then we just print X times Y again. So it's a compounding amount. Correct? So, yep, straightforward enough. I mean, if we were to look at stats and stuff, yeah, these are pretty easy to begin with. Doesn't look like there's any major problem points, like, for most of it. Maybe 19 looks like it might be difficult. And 25, well, no, that's because you need to beat all the puzzles to finish 25. Okay. Time for day 3. Day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers, called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. What? For example, given the following diagnostic report, so we look at the first bit. Also, if we look at the first column, the most common digit is 1. What if it's a tie? I'm guessing that doesn't happen. Alright, so let's just use so what did they refer to these as? They're just numbers. Alright, we'll call it nums again. Alright, nums equals, just do line.strip. Right. So for each bit, are we just trying to find the gamma rate right now? Oh, the epsilon rate is the least common bit. Interesting. All right. Okay. What's the best way to do this? I guess we want to build so these are just empty strings. So for I in range length of just so for every take one of the nums and for each of its bits. So for the we're going to find the most common, so bits equals, let's say, okay, num I or num in nums. So we're just basically taking the column as a generator. Zero count equals Should we just, I don't know, just make it a list. Equals bits dot count O ones count. Should we just say zeros ones equals bits dot count 1? I assume there's not going to be any tie. So if zeros is bigger than ones, then 0 is the gamma plus equal 0, epsilon is equal 1, else, I mean, also, you could just find the most common and add that to gamma, and the least common and add that to epsilon. But how do you find the, what's the nice, easy way of finding the most common? You could use max, something with max, I don't know. So that gives us, let's see what we get. They should be inverse of each other. Yeah, okay. And then we want to multiply them. So we want to take print int we want to convert binary to I forget how to use this method properly. Let me just quickly Google it. Python convert. You just do int, don't you? No. Decimal to binary would be use bin. And if you want int, you would use int2. Int base 2. Yeah, that's right. Okay. So it's int gamma 2 times int epsilon 2. Is that what they wanted? To multiply them? Correct. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Alright, this is a more wordy one. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. What? Alright, the bit criteria says if we were looking for oxygen, we want the most common. Wait, you determine the most common value overall in that column. And then restrict filter to those numbers with that bit, right? If 0 and 1 are equally common, so that can happen. And it wouldn't matter if it happens because... no, it would matter. In the part 1, it would matter, wouldn't it? Well, apparently it didn't. They're equally common. Keep values of the 1 in the position being considered. Oh, it will matter here. So they devised it so that it won't matter here, but it might matter here because now you're filtering. So what you have left, it might, they might be equally common. I see. Keep values with a 1 in the position being considered. Alright, I don't need the example. Just need to follow this process. Alright. So let's start by computing the oxygen rating. Wait, okay. I didn't read... hang on, so you do that bit criteria and you keep discarding numbers and so on. If you have only one number left, stop. This is the rating value for which you're searching. Otherwise, repeat the process, considering the next bit to the right. Okay, okay. That was the stopping point. So... that's interesting. Alright, so, so let's say oxygen nums equals a copy. Oops. It's like a clean copy of nums. So we're going to be filtering it. Then we do this process here. So we go item range. Okay, let me just... k equals length nums 0. Alright, so we go through the bits. Let me say... so the bits is that column. Got the column. we've got the number of zeros, the number of ones. Then we say most common equals. Now, there's a tie condition which we have to keep as well. So it's either you go with the most common, or if they're equal, then you go with 1. So we want to say equals 1 equals 1 if ones is greater or equal to zeros, else 0. In fact, it's not most common, it's just like the bit, filter bit. Alright. And then we have to filter this, so we have to say oxygen nums equals, so it's going to be num for num in oxygen nums if num I is the filter bit. So we just keep all the ones with the filter bit. So we just rewrite that list. I'm sure there's a more efficient way you can use MapReduce or something, but we'll just make a clean copy every time. If length of oxygen nums is 1, break. Otherwise, we just go to the next bit. So if that happens, then we've got our oxygen generator rating. Oxygen rating equals just turn it to a decimal. And we have to do all of this again, but just the other way around. So we have to say CO2 nums equals CO2 rating will be that. Then we want to print oxygen rating times CO2 rating. Is that what we want? And that gives us the life support rating. All right. No, my first incorrect answer. Your answer is too high. If you're stuck making, okay, it's easy to get this wrong because I'm probably skipping steps here. Also, I did some copy pasting, so I gotta make sure we don't have... looks okay so far. Don't see any obvious issues. So, we can use the test example. Let me just read the description again. So you keep the ones which match the criteria until you've got one number left. Starting with the first bit and moving to the second bit and so on. Oh! I think I made a mistake with the CO2 one. Hang on, so... 0 if zeros is greater... Oh, no, I've done this... Yeah, no, that's wrong. So it's less than. Because we're taking the least common. But we're breaking ties with 0. So if they're equal, it will be 0. If it's less, it will be 0. Okay, I think that might be the issue. Correct. Okay. First mistake. Looks like it's a continent or something. Although we're in a submarine. What was the story again? We are... just on a ship. And then in a submarine. Subnautica. Alright. That's 3 done. On to number 4. Day 4, giant squid. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see... Hello. If he then... think you're a little late to this one. Well, better late than never. Soon we'll have the much coveted 500 stars and be up to date for once when the actual advent of code comes this year. Have you done all the past years yourself? Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Is that our first wiki link? Bingo. I've done none. Oh, okay. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. If all numbers in any row or any column of the board are marked, that board wins. Diagonals don't count. Okay. We're just gonna code bingo here. Submarine has a bingo subsystem to help passengers pass the time. It automatically generates a random order in which to draw numbers and a random set of boards. I've done some random little challenges of that sort, but they don't hold my interest too much. Okay. Yeah, out of the past years, I think I did like 3 of them live, maybe 4. The first one I did live was 2019, like while the competition was actually happening. And there was a gap. And then I did these last recent 3, 22, 23, and 24 live. And then I went back and sort of did all the past archived ones. Yeah, that's been 1 full decade. After the first 5 numbers are drawn, there are no winners, but the board's marked as follows. Okay. At this point, the third board wins because it has at least 1 complete row or column of marked numbers. So when there's a winning board, find the sum of all unmarked numbers on that board. Then multiply that sum by the number that was just called when the board won, 24, to get the final score. Okay. So it's just a bit. Well, okay. We just need a function to mark numbers. 0 is a number as well. We need a function to mark numbers and a function to check that all numbers have been marked. Like if we mark it, we could just change it to an X or something, because we no longer care about the value of it once it's marked. We only care about the unmarked numbers. And then it's a case of looking for rows or columns that are all X's. Okay. Alright, so this might take a little bit more in terms of like helper method coding. We need to have so those are the oh man, okay, fine. So the first line is just the numbers that are called. So that's the numbers. And then we've got a blank line. So how... So we've got a blank line before each board. So... I'm trying to think what the cleanest way to do this is. Let me just see what we get here. Nope. Got split. Split on comma. Oh no, not like that. Okay. Wait, what? What? Wait, why is it printing like that? 25, 29. For line in F... Oh yeah, because it's got the... Alright. Thanks for the good luck. Okay. So we need... Alright, let's just turn lines equals let's just load all those into... I just want to see that this has what I think it has. Alright, let's just do a bit of cleanup here. But we want it to be like, yeah, that's what I want it to look like for now. Alright, so there's a blank line and then there's a bingo board. Alright, so that's how we do it. Okay. So... for I in range... So I think we want to take every sixth entry. So it's going to be I starts at 0, so that just this blank one here. 1, 2, 3, 4, 5, and then it goes to 6. All right, so for each value of I is just this blank one, and we'll take we'll say a board equals like an empty list for k in range 5 board dot and so be lines I plus k, I plus 1 plus k. And then I think we just want a list of boards. This is the best way to store them, I guess. So that is a board. Okay, good, good, good. So we need 2 helper methods for boards. One for marking it. So define mark board with num. So given a board and a num, I want to mark that number on the board. So we just say for I in range 5, for j in range 5, if Alright, so board I j equals num. Just change it to an X. That's marks them. And this method will check if a board is a winning board. So in this case, we just need to check every... what's the cleanest way to do this one? Okay, so we say for row in board. So if we find a row where all its elements are X, then we return true. And then for column, so column for j in range 5, column we do a similar thing. We say if all x equals x for x in wait, so this time it's going to be like board ij I in range 5. I mean, we could transpose or something. That might be a cleaner way of doing it. So if all... return true, yeah. Otherwise, return false. So that's how we know if a board is 1. So now we just play bingo. So for num in nums. So a number is called. We go through the boards for board in boards. First, we mark the board. Mark board that number. If is win board then we're done. We just have to total the score. So for row in board, so if it's not an X, score plus equal X. All right. Print score. Is that what they wanted? Then multiply that sum by the number that was just called when the board won. Okay. So it'll be print score. So it'll be score and then multiply it by num. Print score. And then break out of that for loop. Is there a cleaner way of doing this? I hate having to do those flags, if we could say. Okay, fine, do it like this. Done equals false. Alright. I mean, the first time we print it will be the answer anyway. Correct. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. Figure out which board will win last. Once it wins, what would its final score be? Okay. Alright, we can just be a bit, save some time here and just basically just print out every board. Okay, so... let's say we don't break out. We just keep playing bingo. But when a board wins, we just want it to, how do we... just say... so the moment it wins, score equals 0, blah, 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 print the score, print the score. Let's just change the board equals win. And then for board and boards, next time we go through the loop, if board is win, continue. So now we're just going to print all the wins of the boards in order. Well, why are we getting zeros? Oh, because it's capitals. There we go. Why are we still getting zeros? So we've changed the board to be win. The moment a board wins, we compute the score and then just turn the board into that string. So we shouldn't ever encounter it again. The zeros are probably from... like, you can get 0. The score could be 0, or the number itself could be 0. Why there's so many? No, something's wrong. Why are there so many 1175s? Messed this up. Alright, we've been taking shortcuts. Let's just... What was it they wanted? They want the final score of the last board to win. So the first one to win was this one, 63424. See, these are all sensible numbers. Then we got these. So they're smaller numbers. That makes sense because... if you keep removing numbers, so if a board is really late to win, then it's not going to have many numbers left on its board, so the numbers will get smaller. Although, why does it suddenly get bigger? Why does it follow this trend? Also, there's too many values here. Something's up. Nums. How many boards do we have? got 100 boards, so there should only be 100 values. Yeah, this is too many. What is going on here? I've done this in a really unclean way, though. Okay, how do we fix this? Oh, hello, iBlink. Thanks for the good luck. Alright, maybe we have to do this properly, so we just have to say, I board in enumerate boards. Alright, let's just keep track of the index of the boards so we know what. Let's just change it to, I don't know, Z or something. Z board. Print Z score. Alright, I want to see the index. See if we're repeating indices. Yeah, why are we going... So we reached 99. Why do we go back to 0? What? Board. Oh, because that doesn't do that. That doesn't change. This is just new scope. This just changes board, some variable called board to be win. But that is not this board. This will then go into boards and find a board and call it board. So those are not the same boards. Or what we should be doing is just changing boards equals win. Change it by index. There we go. Now every board is only wins once. Hello, Quantum. Yep, that's some good coding there. When in doubt, RM, RF. Num in nums. Okay, so that's a bingo. We're basically programming bingo right now. Bingo against a giant squid. 2, 3, 5, 4, 1. Hooray! On to day 5. We'll just update the stream. Day 5. Alright, day 5. Hydrothermal venture. You come across a field of hydrothermal vents on the ocean floor. We've got a wiki link. Hydrothermal vents. Does wiki not have a dark mode? Oh, it does. Oh, my eyes. Yeah, this year is basically the year of Subnautica. This coding year. These vents constantly produce large, opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents for you to review. For example. By the way, Quantum, are you planning to do any Pokemon / Plants vs. Zombies? I'm guessing you don't want to do Pokemon trading cards, because I know there's like a million Pokemon games that need to be played first. Or maybe not that many. Pokemon trading card game was quite early on, but there's still base Pokemon, which came before it technically, so... Plants vs. Zombies is fun. I'm halfway through it. Each line of events is given as a line segment in the format x1, y1 to x2, y2. So these are the coordinates of one end, and the coordinates of the other end. Okay, so it's just like a line in 2D from one point to the other point. For now, only consider horizontal and vertical lines. Lines where either x1 equals x2 or y1 equals y2. So it'll be like 9-7 to 7-7, which means it's 9-7, 8-7, 7-7. Each position is shown as the number of lines which cover that point, or dot if no line covers that point. Okay. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger. So we're basically just trying to basically every point in space, if there's every time a line runs through it, we add 1 to the count. And then see which point, how many points have 2 or more. So we can use a hash map for that. Easy enough. So those are our points. All right. For line and 3 lines. So we've got like this thing here. So we've got A, B equals line dot strip dot split on that separator. Write it in Rust, you coward. I should really, welcome in Slinky, I should really try other languages, but for these types of problems, Python is just the best. Like, it's undebatable. Especially as Eric loves to throw in lots of problems where you're doing tricky things with strings. And occasionally things with graphs as well. So A is the left part, B is the right part. Or maybe we should just call them left and right. Left, right, then left equals X in split comma, and then right is r dot split on the comma. Okay, so that unpacks those. So they said consider only horizontal or vertical lines. So we basically just ignore a line if it's not. So if left 0 is not equal to right 0, so the x values don't match and the y values don't match, then we skip that one. So we look at only the horizontal or vertical ones, and then what? We want to okay. Just do this with a for loop. Okay, so we want some sort of hash map called, well, a hash set called no, not a hash set, because we want to count how many times we hit each one, so it'll just be a dictionary. Points equals just an empty dictionary or a default dict. Okay, so interpolating the line, we'll go for x in range. You would have to take the minimum of left 0, right 0, up to the maximum of left 0, right 0, inclusive wait, no. You need to know which direction you're going though. Well, it's always going from, well, I'm going from the minimum x to the maximum x. And if the two x values are the same, then this is just redundant and it will just move to the y's. So if I just copy that line and do this for y in range left 1, right 1, left 1, right 1. So yeah, if they're the same, then that should just be one value. So that should hit every point, and then we say points. So it'll be x, y plus equal 1. And then result equals This basically and of P for P in points if wait, no, we don't have to do that. We could just say just say sum of v is greater or equal to 2 for v in points dot values. So the counts, we just count up all the ones which are greater or equal to 2. Is that what they wanted? Yeah. Five, 1, 4, 7. Correct. Part 2. Unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You need to also consider diagonal lines. I expected that they would only be at 45 degrees. That makes it way easier. Then our code should already work. Because of how I've written the X and Y ranges. Yes. So the code should mostly already work. We just need to put back in the just don't do that. I mean, if I was doing this properly, we would have a part 1 and then a part 2. It doesn't matter, we're not trying to perfect our code. It's taking a long time because there's just a lot of values to go through. Nope, too high. Was that assumption wrong? Need only 45 degrees, not any other slopes. But they said it will only ever be 45 degrees, or horizontal or vertical. So they won't give us any other slopes. Alright, there might be something wrong with my assumption here. Let me look at this bit here again. So no matter what the XOR values are, we go from the minimum X to the maximum X. Seems right. Go from the minimum Y to the maximum Y. So that should cover both the... Oh, I see the problem. this is now, yeah, this is not, we're not doing a line, we're doing an area here. This is not correct for the diagonals. We need, yeah, no, this is not right. Yeah, what this is computing is the entire area under the line. Every possible x and y such that x are between those values and y are between those values. So what we need is, it might just be easier if we just split this into the cases properly. So if x, no, if it's horizontal, if the x's are equal, then we just do for y in range that. Yeah, and then if it's vertical, I mean, we can still reuse that code. Okay, hang on. If left is that, or okay, so if it's a horizontal or vertical, this code should work fine. So this is computing the area, but the area is the correct answer in the case where it's horizontal or vertical, because it's 1D. Else, and this time we would have to say just say min x equals min. Just get some values here. Min. Oh, did the music stop? Min. You don't need that code path if you have a general line algorithm. No, you do if well, the way I'm writing this won't work for the horizontal case, because I'm just going to add one to hang on. We just need to, okay. I think the better way to do it is just have the delta. So delta dx basically is +1 if we're going up, going positive, and negative, -1 if we're going negative. So dx equals 1 if right 0 is greater or equal to greater than left 0, else -1. Okay, so that's the direction of the delta x. And similarly, dy equals 1 if it's greater than 1, it's -1. Okay, now that we've got that, we can just say the starting values on how many Alright, just say k is going to be the number of times we had them. So k equals okay, and then we just do for z in range k. The point will be left 0 plus z times dx left if you gave the dx and dy the option of being 0, it works with straight lines too. Yeah. Well, sort of, but here I'd be adding the point in multiple times. No, because yeah, k would. Well, I would have to. Yeah, it would work. So left plus z times dy. Point is equal 1. So it shouldn't take as long to compute now because it's doing lines instead of areas. 16,000. Damn, too low. I mean, I could go for a general case. Means I don't have to maintain two different things. So if I did that, it would be like oops. If basically that. Oh, k values. No, I see the problem. We need to. This range isn't correct. So k is the distance. Okay, that's what that means. But we also want to include the final value, don't we? So it should be k plus 1. K... Yeah. So when z is equal to k, that is the endpoint. I was missing the endpoint. And that's a general... Okay, so yeah, that should be okay. Alright, try that. That's smaller. That must be wrong. They said it was too low. Shouldn't be smaller. If I go back to what I had before, but what's wrong with this? D, right? Ah, yeah, no, this is wrong now because it has to be the bigger of the two, so it's gonna be because one of them might be 0. So now k is the actual length. $16,925. So that's just like a 20 more than what I had before. So I was missing the endpoints of the lines. Which sometimes overlapped and sometimes didn't. Yep, that's it. Yeah, I don't like this. Python doesn't really have a switch case break, so you have to assign things in a bit of a weird way sometimes. Unless they have introduced something recently, I haven't really kept up with Python's updates. Because that looks hideous. I suppose you could say... It's not too bad, but it's just... I mean, if you're using a switch case break like in C++ or something, it would probably have similar length anyway. But yeah, that's part 2. And part 1, you'd have to... Right, if I was doing the live competition, I would write it properly and have a part 1 and a part 2 separately, but we're not, so... It's that. No, I'll just put part 2 just so it's clear that this is part 2. All right. Can go for day 6. Day 6. The sea floor is getting steeper. Maybe the sleigh keys got carried this way. The massive school of glowing lanternfish. These are lanternfish. Swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. So each lanternfish is basically a timer. Cyclic timer. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. So suppose you have a lanternfish with an internal timer of 3. Then it goes to 2. Then it goes to 1. Then it goes to 0. After another day, its internal timer will reset to 6. It would create a new lanternfish with an internal timer of 8. Okay. The lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8. Okay. Alright. This list means that the first fish has an internal time of 3, the second fish is... Alright. These will grow exponentially, so I don't think we should store it like this, but instead store a count of how many of each internal value we have. Because that means we'll have at most 9 values rather than a list of exponentially growing values. I'm guessing this works for part 1 if we do it the slow way, but I'm not going to. Well, that's already a lot of fish. So we do have to be efficient here. Okay. So let's say counter. Fish equals counter Then we're going to count using just put this one here. So we take the line, strip it, split it on the comma, cast it to ints, and then just make it into a counter. So what it should look like is that. That's how many we have with that. That's how many we have with that, and so on. Okay, good. So what was the question? After 80 days. All right. So for day in range 80. So basically we want a new counter equals just an empty counter. So we want to say for timer count in fish dot. So basically we're just looking through the counts and the corresponding internal timer value. So if timer is 0, then this is where we create new fish. So first we will just, all these fish will just reset. New counter. And they reset to six, but a new fish starts with 8, so it's going to be new counter 6. Let's see, equal count and new counter 8 plus equal count. They each produce one more fish. Else we just count down, so it'll be new counter timer -1 plus equal count. So we've got this new counter, and I think we just want to replace fish with the new counter. So now we have the new population of fish. And after 80 days, just see what it looks like. Look at those numbers. That's why you need a counter. I mean, you could still do it in one massive list, as is implied in the on the site, but it'll probably take a long time and you'll have a lot of values, and part 2 is probably going to ask in the millions or something, in which case it just won't work. So what was the question? How many lantern fish would there be total? Okay. Print. Print sum of fish dot values. I mean, hopefully we don't get an off by 1 error if I've not done the right number of days or something. Like, day 0, so it's 80 days after the starting point, right? So, correct. Okay, good. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of that many lanternfish. How many lanternfish would there be after 256 days? So I think because we've done it as a counter, it would never grow exponentially. The numbers will get bigger, but we'll only ever have 9 values in the count in the counter. So this should be straightforward. This is probably the first problem where you have to do something a little bit smart. But I think we could just change that to 256 and it should be fine. There we go. Instant. Correct. Nice. That was a good problem. That's where you have to be at least a bit smart about how you're handling the data. The previous problems are mostly you're just sort of coding things as they give you. Pretty much exactly as they spell it out. But this was the first time you had to not do that. Because if you did that, for 256 values, you'd have that many values in the list, and you'd probably run out of memory. Yep, that's a good problem. I like that one. So, 7. This might be the last one I do this stream. Day 7, the treachery of whales. Oh, those devious whales. A giant whale, that's a whale. Sperm whale, specifically. Has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. Thing is, whales don't eat... They don't really eat big things, do they? Their throat is like the size of a... they could only eat something as big as a melon, probably, at most. They mostly eat plankton. Well, I don't know about the sperm whale specifically, but I don't think they eat anything big. Just like tiny little fish. So they couldn't even swallow you. They could hold you in their mouth, and that has happened in real life. There have been cases where divers or swimmers have been picked up into the whale's mouth and injured, but you can't be swallowed. Anyway, they seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. Well, this is really becoming like Subnautica now. The crab submarines all need to be aligned before they will have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. Oh, yeah, this is a classic problem. For example, consider the following horizontal positions. This means there's a crab with horizontal position 16. All right. So I believe the answer is you pick the median value and bring them all to that. Not the average, but the median. If you go with the average, you can actually get a wrong answer, I think. But yeah, if you pick the median, then that minimizes it because all the ones to the left increase, all the ones to the right decrease. And that minimizes the amount of change you need to make. Okay. Those are the crabs, okay. All right, so we've got the crab values and basically we want to sort them and then we want to pick the median. The crabs. I wonder if there's a built-in routine for finding the median, but I mean we could just do crabs length of 2. And then the answer will be basically how much it costs to bring them all to the median, I think. So for crab in crabs. So fuel is going to be the absolute value of crab from the median, how long it takes to get there. And then we print the total amount of fuel. I think that should be the answer. Correct. This is a good problem because I think a lot of people will use the average. The first time I saw a problem like this, I think was in the Google Code Jam. And it tripped up a lot of people. Because they just immediately, instinctively went for the average and just tried to get every crab to go to the average location. But that's wrong. And you could prove it's wrong by just having an obscure example where there's like a million high values and one small one or something. So let's say you had like a 1,000 crabs at 100 and 1 crab at 1. And you took the average. The average is going to be somewhere in between, very close to 100. So then all those 100 crabs are going to move to the average. That's a lot of fuel spent. But the median would be 100 because practically all of the crabs are already at 100. So then none of those crabs will move to the median. Only the 1 crab at 1 will have to move to the median. That's how you minimize the amount of fuel. But you can prove it mathematically properly. But yeah, median. It's often the case you need to use the median and not the average in problems. Part 2. Crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, Each change of 1 step in horizontal position costs 1 more unit of fuel than the last. Okay. So it's no longer going to be the median. Now you're really trying to minimize. So now you're no longer trying to split it halfway, but you're trying to minimize the max. Like you're trying to avoid any crabs with huge amounts of movement to some extent. I mean, at this point, you just have to compute the cost for every possible midpoint, I guess. This costs a total of... Determine the horizontal position that the crabs can align to using the least fuel possible so they can make you an escape route. How much fuel must they spend to align to that position? At this point, I don't think it's going to be anything nice and clean, like just using the median. If it's linear, it's the median. This is not linear, but it's not even exponential or geometric. It's using a 1, then 2, then 3. That's not. So I think we just have to. How many values have we got here? Yeah, it's not a big range. It's like a 1,100, 1,200 or so. 0 to about 1,200 at most. So we could just try every possible midpoint and just compute what the cost is of moving all the crabs there. So and what are these numbers called? The triangle numbers, where you add 1 plus 2 plus 3 plus 4. Or triangle numbers. I'm trying to think if this is just going to be... So it's going to be 1,000 different values we try. And for each of those... So how many crabs have we got? Each of those, we just compute it for every crab. There's 1,000 crabs. Okay, so it's 1,000,000 operations. That's fine, we could do that. So... for midpoint in range, so the lowest one we'll have is min crabs, and the highest one we'll have is max crabs. So for each of those midpoints, we want to compute the amount of fuel spent . So the distance will be the absolute value of crab minus midpoint. So if it's a distance of x, then the amount of fuel spent is going to be one plus 2 plus 3 plus 4 up to and including x. So the formula is the arithmetic sum formula, which I just gonna Google. Call this D. The arithmetic sum formula is gonna be we're starting at 1, so it's the simplified version. It's just going to be like, so it's going to be 2 plus 2 plus n minus 1 times the difference, so it's just 1. Okay, so that becomes d plus 1. Oh yeah, of course, it's just d plus 1 times d over 2. This is the standard triangle sum formula. Why doesn't it like that? Statement seems to have no... Oh yeah, okay. So that should be the sum fuel plus equal. I think that's it. If best fuel is none, so we haven't tried anything yet, or we found a new best fuel, then best fuel equals fuel. So after this, we've found the best amount of fuel to use. And it's that. Correct. Just thinking if there's any simple formula for this. So we're basically computing, minimizing the sum of that. I don't think there is, because that's quadratic, and you're minimizing the... Yeah, it doesn't have the nice neatness that you have with the median. This is not linear anymore. So I don't think there's some like simple average like the mean or the harmonic average. I can't even remember what the harmonic average means, or just something nice and neat like that. I think you just have to compute this sum. Let me just print what the midpoint was. Out of interest. So that was the best. It was at 470. 70, interesting. And what was the median? median was 337. It's a bit higher than the median. What was the average? $470. So it's the average. Oh, hang on. So the answer is actually the average. Is that always the case? Oh, I can't think right now. I've probably seen similar problems to this before. There's, yeah. So you're minimizing a sum of quadratics. There's some reasoning, but I think, yeah, the answer apparently is just take the average. So median if it's linear, average if it's quadratic. I think if I were to bother to write this out with pen and paper, I think if you were to start putting these D is crab minus pip point. You put that into this formula here, and you're summing up all the fuels over all the crabs. I think, yeah, I think I can sort of see why it reduces to minimizing this. Because this becomes... You have to write out the sigma notation, and I think it will just fall out somehow. You end up minimizing that, and for the median, you're minimizing the not minimizing anything, you're just taking the middle value. Anyway, I'm not too bothered about the maths behind it. It worked, and we didn't have to. So he could have made it harder, and made the value so big that you couldn't do that, and you had to work out that it has to be the average. That would have been a good problem as well. Same for the median. Except, like, you couldn't make the values... You couldn't make... The median is linear, so it's not like you could make the input so big that you can't... Computing the median is equivalent computationally to computing the just the sum of all the fuel values and finding the minimum. Actually, not quite. Median is actually easier. Anyway, so that's day 7 done. take a look at the old leaderboard. Alright, we're in the top 10. Captain Coda's leaderboard? I don't think Captain Coda is ever intending to come to... Oh! For some reason, Captain Coda has done part 1 of day 25. Why? Of all the problems to do, why would you do 25? Specifically. Maybe he meant to do a different year and he accidentally clicked on the wrong year and then just ended up doing this problem before he realized. I don't know. Interesting. Okay. Alright, so clearly it gets harder after day 7. And of course, this was back in the days before ChatGPT, so people were solving the problems properly. So these are the times: 1 minute, 1 minute, 4 minutes, 4 minutes, 3 minutes, 2 minutes, 1 minute and a half. I can believe that. They're all recognizable patterns. Once you recognize what the problem is, and you've probably seen it before, then if you've got lots of stuff stored where you solved it before, you just have to call that up. What took the longest? This one. Problem 4. The giant squid one. Yeah, because this you have to format the boards and stuff. So that was bound to take longer. Spend more time parsing. Alright, well, we did 7 problems in 2.5 hours. That's good. We just have... So basically a quarter of the way, just over a quarter of the way. But they get harder, for sure. And this was the year... So 2019 was the year with the heavy int code. Every other problem was an int code problem, which some people liked, some people didn't. I quite liked it, but I also found it quite taxing because it means you had to get all the past int code problems correct to be able to continue, so it's not independent. So, like, you can't just jump into a later problem. You have to kind of do them in sequence and get them right. Which I can see being frustrating for people who just can't solve a problem and just want to move on to the next one, but you can't really do that. Alright. Stop there. I doubt that there's anyone online doing Advent of Code. I'm not even going to check. It's not the time of the year, so we won't raid. Alright, well, I'll continue with this over the coming month. See you next time.